Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the definitions and terminologies related to the Module 1, that is Introduction to Engineering Mechanics. Let us begin the first definition, that is what is engineering mechanics. So, engineering mechanics is the branch of physics or branch of science which deals with the study and effect of the force system acting on a particle, and the particles made up, different particles made it as a rigid body which may be at rest or in motion. Now here, the branch of physics here, if we explain here, the force system, the effect of the force on a particle or on a rigid body. So rigid body means when the load is applied on the body, the distance between the particles remains same, no change, or it remains unchanged. Then the force of effect, that effect of the force are going to be studied in this course, that is known as the mechanics. So, which may be at rest. Suppose the branch of physics which deals with the study of the effect of the force system acting on a particle or on a rigid body when the body is at rest, it is known as the statistics. Statics, not statistics, statics. Or the force that deals with the study of the effect of the force system acting on your body or on your particle, that body is in motion, then it is known as dynamics. So thus mechanics is again divided into two parts. One is statics and another one is dynamics. The dynamics again divided into two parts. One is known as kinematics and another one is kinetics. Okay, so thus mechanics is divided into two parts, statics and dynamics. Dynamics again subdivided into two, that is kinematics and kinetics. Okay, in statics, what are the chapters that are going to come in statics? Statics, it comes as coplanar concurrent force system, coplanar concurrent forces, and second one is friction, and the third one is center of gravity, centroid, moment of inertia calculation, and next one is called stresses calculation. Stresses means what is the reaction of the forces. So in this category, the friction is going to be studied or when the body is at rest, and centroid and center of gravity or moment of inertia is also bodies under rest, and stresses is also reaction forces calculation when the stresses are in static condition. Yes, of course, the stresses are always in static condition, but the loads are acting on the stresses or under static condition. The next definitions are what is statics. Statics deals with the forces acting on the stationary bodies. That means stationary bodies here which are in equilibrium condition, which means at equilibrium. Now coming back to what is the equilibrium, immediately the body, whether it is in equilibrium or not, how can we know? Again, when the body is at equilibrium, equilibrium comes under again equilibrium. This equilibrium portion means the body will be in equilibrium. That means the conditions are there, equilibrium conditions. If those conditions are satisfied, then the body is in equilibrium mechanically, or according to engineering mechanically in equilibrium. Okay, now here what are the equilibrium conditions are? The equilibrium conditions we are going to study here, there are three equilibrium conditions. One is sigma fx equal to 0, another one is sigma fy equal to 0, and the third one is sigma m equal to 0. What is the meaning of this sigma fx? Sigma fx indicates that equilibrium condition, algebraic sum of all horizontal forces equal to 0. Now, Again, horizontal means it is left towards left or towards right. If you consider the coordinate system, if it is towards, from my view, is it towards right, is the positive, it is next towards left, it is negative condition. This one here, algebraic means the terms may be positive and negative terms may be there in this condition. That's why algebraic sum of all horizontal forces equal to 0. What is the meaning here? The algebraic sum of all the horizontal forces. Suppose if the body is acting, some of the forces towards right and some of the forces are towards left. So it is 10 newtons or 10 kilonewtons, here 20 kilonewtons. And some are with inclination, then some are with inclination, having some angle, that is theta. Here, that is some 30 degrees, you consider it. It is 25. So, if you resolve it, again we are going to study all the things in this engine mechanics. Now, this inclination force, is this horizontal or vertical? Now, we have to resolve into horizontal and vertical component. When it is vertically downwards, that is 25 cos 30. When it is horizontal, then it becomes 25 sin 30. This is horizontal, here it becomes, and vertical component 25 sin 30. Now, the sigma fx, how to make it sigma fx? The positive in this direction, it's positive, in this direction it's negative force component is, in this towards right is positive force, towards left is negative force. Now 10 kilonewtons is positive. How to apply here? 10 kilonewtons minus 20 kilonewtons is the negative, opposite to the 10, that is negative towards negative. And what about one more time? 25 sin 30, that is a positive, 25 sin 30. This is known as sigma fx. That sigma fx equal to 0, I said, that is sigma fx will come. If it is equal to 0 means it is horizontally in equilibrium. If it is not equal to 0, that means that is not in horizontal equilibrium. It is unbalanced in horizontal direction. The next term is sigma fy equal to 0. What is sigma fy equal to 0? Algebraic sum of all vertical forces equal to 0. The vertical forces means vertical upwards or vertically downwards. Yes. Again, if we consider here, it is vertically upwards is a positive, vertically downwards is negative. Okay. Now, here some of the term, only one term is left. Then such in the way we use it here for sigma fx, similarly you have to make it sigma fy. Those forces, the sum should be equal to 0. That means it is completely balanced. That means it is in equilibrium vertically. If it is not equal to 0, then those are unequilibrium conditions. Okay, we'll study those unequilibrium conditions also. And sigma m equal to 0. What is sigma m equal to 0? That is momentum equilibrium forces. So algebraic sum of all momentum equilibrium. The momentum matter comes into the rotation. This m causes rotary, the clockwise or anti-clockwise motion. This moment causes, suppose it's the fixed here. If you apply the force in this here, if you apply the force downwards, it is causing the rotary motion. That force causing the rotary motion, is about which point? The perpendicular distance. Force into perpendicular distance, that is known as momentum. This momentum again two types is the clockwise momentum, anti-clockwise momentum. So algebraic sum of these moments about any point, arbitrary point, should be equal to 0. If it is 0 means it is a balance, nullified. Okay. This momentum equilibrium, that means clockwise moment and anti-clockwise moment are equal. Then it is known as, that means that sum should be equal to 0. Then it is momentarily equilibrium. So, if the stress is under static condition, these three equilibrium conditions should be satisfied. Then the body is at rest. If it is not satisfied, what will happen? Those are unequilibrium conditions. The unequilibrium conditions, what are the unequilibrium conditions are? Unequilibrium condition, that is sigma fx is not equal to 0, sigma fy is not equal to 0, and sigma m is not equal to 0. That means algebraic sum of all horizontal forces are not equal to 0. That means both are not equal. left side direction, right side direction are not equal. That is the meaning here. That means it is unbalanced condition, unequilibrium. And sigma Fy, algebraic sum of all vertical forces are not equal to 0. Sigma m, the moment equilibrium, algebraic sum of all moments, clockwise and anticlockwise moments are not equal to 0. That means what will happen? Sigma Fx is not equal to 0. The meaning, the significance of the mathematical expression of that is sigma Fx is not equal to 0. That signifies the body is not in equilibrium in horizontal. Sigma Fy is not equal to 0. That means the body is not in equilibrium vertical direction of forces. And sigma m equal to 0. That means the body is not equilibrium in moment conditions. That means it is completely in unequilibrium conditions. For our calculations or the reaction forces, so for our calculation, the body should be under equilibrium. That is sigma Fx equal to 0, sigma Fy should be equal to 0 and sigma m must be equal to 0. So understand, then we can go for next. What are the calculations and all. So there is a lot to speak about unequilibrium conditions. So I want to give it just a glance, just a glimpse of about the condition, unequilibrium conditions, what it will affect. When the body is in unequilibrium, then it causes unbalancing. This unbalancing of forces leads to what? Vibrations. That the vibrations causes damage to the structure or to the body. Suppose if we consider a car or automobile vehicle or four-wheeler, there is unbalancing of the front wheel. Then what will cause it? It affects to the axle. That axle affects to the crankshaft and complete to the engine damage takes place. And not only that, the violent, not only the structure also damage. That is one of the, about engine. Whatever the structure, it causes the loosening the parts of the body. So when the person is a driver or the passenger feels uncomfortable during driving, this is interconnected parts. These are effects of these unequilibrium conditions affect. Alright, let us begin the next definitions. That is what is statics. Statics, as already mentioned. Next come to dynamics. Dynamics means study of the forces on, simple definition, it is the moving bodies. Under moving condition, the function of the time will be taking place with the moving dynamics. So application of the forces here, when they are in motion, it is under motion, moving bodies. At rest, it is in equilibrium. Next, what is the dynamics is divided into two parts. One is kinematics, another one is kinetics. What is the kinematics? Kinematics here we consider only, we study the motion of the bodies, not under the motion, not under the consideration of the forces. We don't consider the forces calculation. Here we only consider the motion. What is the motion of the body? The displacement, that is the S. Next, that is the ds by dt, that is known as the velocity, and the dy by dt is known as acceleration. We will study SVA, that means the displacement, velocity and acceleration component. These are three things are going to be studied in this category of the kinematics. So kinematics is the study of geometry of the motion. So it is the use to rate displacement, or rate of change of displacement is known as velocity, and rate of change of velocity is known as acceleration. So these are the function of the time. That's why time also going to be calculated without reference to the causing of the motion. Cause of the motion. What is the cause of the motion? Is the force. Force we don't study here. We don't calculate. Now what is going to be calculated? We don't calculate the cause of the motion, but we study the motion. What is the output of that? So what is the cause? We don't study here. We'll study what is the output, what is the displacement, velocity and acceleration and the time are going to be calculated in this kinematics. So in kinematics, what is the displacement and velocity and acceleration and time? There are equations are there. There are three equations for this. The three equations are, number one, V equal to U plus AT. The second equation, that is S equal to UT plus half times AT square. Then V square minus U square equal to 2US. Okay. And finally V equal to U plus A E times N minus half. So here the point is that these three equations we are going to study for this year. That V equal to U plus AT. where what is the V here? Final velocity. U is the initial velocity, A is the acceleration, T is the time. And where is S? S is the displacement. Again, U stand for initial velocity, T for time, and A for acceleration, again time. And final velocity V square, V is the final, U is the initial, A is the acceleration, and S is the displacement. Now, if you consider the variables U, V, A and S, these are the four things. Now, what about that is the displacement, velocity, V and U comes under the category of velocity, and A is the acceleration. One more is the time. So there are four: displacement S, velocity. These both are comes under the category of velocity, acceleration and time. So the first equation that is V equal to U plus AT, it only gives relation between three, that is velocity, acceleration and time. Velocity, acceleration and the time. The second equation represents the four parameters, the four things. What is the velocity? U, acceleration A, displacement, velocity and acceleration and the time. So displacement is the output combination. Displacement affects velocity, acceleration and time. Whereas the final velocity affects velocity, acceleration and time. Now final velocity, initial velocity, here again three. What are the three? Velocity, acceleration and displacement. Now the point is that these four parameters, this is the displacement, velocity, acceleration and time, are going to be studied in the kinematics. Now coming to kinetics. Kinetics is the branch of, that is also part of the dynamics, but here we consider what is going to be studied, the forces causing the motion are going to be studied here. The branch of classical mechanics that is concerned with the relationship between the motion and its causes. Not only motion and also causes, that means force. Specifically forces and torques. We are going to be studied here, the force and torque. The torque, what is the torque? Force into radius, mathematical, that is the expression, mathematical expression. But forces causes the revolutionary motion, rotary motion. With the force making to rotate the body, what that causing is known as the torque. Okay, that is going to be studied in kinetics. The next definitions are the term rigid body. What is the meaning of rigid body here? A body is said to be rigid when, if the relative position of any two particles do not change under the action of the force. Okay, suppose if we apply the force, I am going to consider here, it is the body, it is a rigid body. You apply the force, such a manner, there is no distance. The distance is between two particles remains same or unchanged. Then the body comes under the category of rigid body. What is the rigid body's opposite term? The antonym of this rigid body is known as deformable body. Deformable body means when the load is applied, the body will get deformed. And mean the distance between the particles will be changed. Then that body is known as a deformable body. Alright. Now again here, coming to here, what is a deformable body? Deformable body, when the load is applied, the distance between the particles will be changed. That means a deformation takes place. So what type of load? Again, when the load is applied, I said load. There are various types of loads. Okay, one is types of loads category. Number one is the tensile load. Number two, compressive load. And three is shear load. So, okay, tensile load, compressive load and shear load. What is the direction of the tensile load? Tensile load, suppose if we consider a rigid body, as I told you, you apply the load in the direction, you pull both the sides, then it is under tensile load. That is the load direction, in this direction. that is the tensile load. When the load is applied towards the cross section, then it is a direction indicates that arrow is the direction of the load applied. Then it is known as a compressive load. Okay, it is a compression load. If it is in the body, you apply it on the both the side, then it is known as compressive load. Then what about the shear load? The shear loads acts parallel to the cross section. Yes, parallel to the cross section of the body. It is known as the shear load. Okay, or tangential to the surface. That is known as shear load. So in just a glimpse about the types of loads, I explained about tensile load, compressive load and shear loads. Alright, here the deformable body, the deformation takes place if you apply any type of load here, tensile load or compressive load or shear load, then the body is known as a deformable body. It remains same under those loads, then it is known as rigid body. That's the term rigid body. Now, to understand better, there are certain terms, there are Newton's laws are highly useful in the part of the dynamics to calculate the displacement, velocity, acceleration and also time. It can, and also force also. So now here Newton first law says that, now it is comes under here the kinetics. Here what it will indicates, the object will be remains at rest or in motion in a straight line unless it is acted upon by body and external force. Motion and force. So the motion and also causing the force, causing the motion, the cause also that it comes under the category of kinetics. Now where is the, it indicates that represents the what is that? That law which states that it remains at rest or in motion. It remains at rest when the force is applied, it will be under motion. When the body is under motion, you want to keep it in rest, we need the force. The force and the motion, the force and rest, state of the position of the body, force and the state of the position of the body, this relationship indicates or denotes or represents, explains the state of the rest, the state of the position of the body and cause of that position is known as the first law of Newton's first law. What about second law? The second law says that the rate of change of momentum of your body is directly proportional to the force. That's why here m into v minus u by t, that is F equal to ma. The force F equal to mass times acceleration. This expression is obtained from the Newton's second law. Okay. Now, this change in momentum takes place in the direction of the force. That's what here. And finally, everybody knows the third law indicates, what is the third law? Equivalent reaction. That the third law states that for every action, there is an equal and opposite. There is an equal and opposite reaction. So, this Newton's third law also says as a karmic law. If you harm somebody, you will be harmed in return. Equal and not required equal. But the Newton's third law says it is an equal and opposite reaction. For every action there is an equal and opposite reaction. Because it matters about the force. So if you apply some force, some load here, some weight, if you carry on your head, then immediately the equal reaction is equal. The equal reaction is required to maintain static equilibrium. So that's what here. When the person is load, okay, when the load is applied on his head, W, it is action on his head. What about reaction? Yes. So this is the reaction R. When W equal to R, then the body is in under equilibrium. When W less than R, or when W is more than R, reaction, that means that is in unequilibrium. Unequilibrium. Okay. If W equal to R, it is in equilibrium. If W is less than R or W is greater than R, then the body is then the body is under unequilibrium, not equilibrium condition. Okay. Now, if W and R is acting, when W is acting downwards, R is acting upwards. Okay. Now, if you consider the sigma Fy equal to 0, that means that is vertical force W is downwards minus R is upwards. It should be equal to 0. then the body is in vertical equilibrium. That means minus W plus R equal to 0. That means W equal to R. Does W equal to R is known as vertical equilibrium. That means downward force equal to upward reaction force. The both are equal. Then it will be in equilibrium. Otherwise, what will happen? When W is more, then reaction, resistance, the carried capacity of the person is not equal to the weight. What will happen? This weight moves downwards. Okay, that means you feel more stress. Okay. Now coming to next third law, that is what equal and opposite reaction you have studied. The next definition is that the law of transmissibility. This law of transmissibility indicates, is very important in calculations of the reaction forces, especially in the part of statics. Now it states that the state of rest or motion of a rigid body is unaltered if a force acting in the body is replaced by another force of the same magnitude and direction, but acting anywhere in the body in the line of action, their placed force, the replaced force. Suppose, what is the meaning here? If you are applying the force F, this in the place of F, you can replace the effect of the force by, here it is pushing. It can be replaced along the action. The F can be drawn like that. The effect remains the same. Without changing the effect, you can change, you can replace the force, direction. The direction is also same. You see, but line of action also same. But the effect is remains same. Instead of pushing the body, here you are pulling. This F is affecting the same as this effect. That can be done by using law of transmissibility for calculating the unequilibrium or equilibrium forces by using equilibrium conditions. Okay, what is the next law? That is called, what is the law Newton's, what is the Newton's law of gravitation? Everybody knows here, the universal law of universal gravity states that every particle attracts every other particle in the universe with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. The Newton's law of gravitation. Next, coming to the here, what is the force system? The system of forces. When the several forces act simultaneously on your body, they constitute a system of force system. What are the several forces are? Suppose in your force, here, the body is acting in this direction, in this direction, in this direction. This is the direction. The effect of all these forces will be at one point. That is known as this is a coplanar concurrent force system. Okay, coplanar concurrent, coplanar parallel force system, and coplanar non-parallel force system. These are all system of forces. The concurrent forces means all the forces acts at one point. Okay, that is known as coplanar concurrent force, concurrent meeting at one point. Whereas the forces which are acting downwards on your body, then it is known as parallel forces, like parallel forces. If it is acting, one is upwards, another one is downward, one is upwards, it is non-parallel. It is a parallel, but unlike parallel force system, it is on a same plane. Then it is known as coplanar, unlike parallel force system. That is the system of forces meaning all about. The next, what is the meaning of the particle? You understand what is the definition of the particle we studied? The particle having considerable mass but negligible dimension. That means geometric property, no geometric property, only mass, considerable mass. As I mentioned about the term rigid body, already explained. When the load is applied, if it is rigid, it remains rigid. If the relative position, when a body is said to be rigid, if the relative position of any two particles do not change under the action of the weight or the force, then the body is said to be under rigid body. Next, there are two things, the composition of the force and the resolution of the force system. The composition of the force means replacement of two or forces by a single force. Then it is known as the composition. What is the resolution? The one single force is divided into two components, two force components. Then it is known as the resolution of the force. Now the process of breaking the force into number of components which are equivalent to the given force. What is the resolution of the force? I'm going to explain it here. Suppose if there is a force acting with some inclination theta. Alright. This force, inclined force, is going to be resolved into two components. One is horizontal, it becomes F cos theta, and another one is vertical, it is known as F sin theta. This F, the effect of F is resolved into two components. One is horizontal, another one is vertical. This system, the methodology of dividing the single force into number of components, into two components, then this process is known as resolution of a force system, resolution of the force. What is the composition of the force? The two forces are acting as this F cos theta and F sin theta are acting. These two forces are replaced, the effect of these two forces are replaced with a single force, that is F. Reverse of the resolution. The reverse of resolution of the force is known as composition of the force. Okay, that's what here, composition of the force and resolution of the force. The next, what is the moment of a force? It is the turning effect produced by a force on a body on which it acts. Then it is known as the moment of a force. What is the rotation of the body takes place because of the moment of the force? The turning effect takes place. So the moment of the force, mathematically it can be expressed as that force times the product of the force times the perpendicular distance or distance between the 2 points where the fixed point and where the force is being acted. That is known as the moment of the force. Suppose it is fixed here at this point, the force is acting here. Now the distance between fixed point and the line of action is the d. What is the moment of the force here? F times d. That is force into, what is the distance? A perpendicular distance here. This is the perpendicular distance. This perpendicular distance is also distance between the point where you are going to consider the moment and the line of action of the force. It is known as the moment of the force. What is the effect of this force? This causes to rotate the body. Suppose the line or beam, rotary motion, it always rotation effect. That is known as the turning effect. You are turning, applying the screw, moving, okay, then it is known as the moment, force. What is the force causing to rotate, to turning, to tightening the nut and bolt, to tightening the screws? What is that? It is known as the moment of a force. This force acts and distance normal to that is known as the moment of the force. The next definitions are, there are few more definitions we'll explain. What is the couple? The two collinear parallel forces of equal in magnitude and in opposite direction, it forms a couple. Collinear forces, the two non-collinear parallel forces of equal magnitude. So, in that manner, you can explain more and more the definitions. So, you can go through what is the moment of a couple. What is the moment of a couple means the magnitude of the rotation is known as moment of a couple. It is a product of common magnitude of the two forces and of the perpendicular distance between the line of action. The next, concurrent force system. There are two types of concurrent forces. One is coplanar, another one is non-coplanar. In a coplanar, in a concurrent force system, the line of action of all forces in a system passes through a single point. That is known as, if it is in a single plane, that is known as a coplanar concurrent force system. Next, coplanar collinear force. What is the collinear? The line of action of all the forces lies along the line. It may be upward or in opposite direction. Then coplanar collinear force system is the line of action is same. It is in the same plane, then it is known as coplanar collinear. Next, what is the Varignon's theorem? The Varignon's theorem states that algebraic sum of all of the moment of all the forces about any point is equal to the moment of the resultant force about the same point. That is known as the Varignon's theorem. Next, what is the equilibrium? There are thermal equilibrium, static equilibrium, dynamic equilibrium. There are various equilibrium equations. Now here they are talking about only static equilibrium. I already explained. If the resultant of a number of forces acting on your body is 0, then the body is said to be in equilibrium. What in equilibrium? Statically in equilibrium. Now coming to the next, that is free body. The free body diagram means very important here in order to, in the case of the statics part, what is the free body diagram? Free body diagram, if your body is isolated from all the contact forces and considering the reaction at contact surfaces which is perpendicular to the surface, it is known as the free body diagram. Okay, free body diagram means isolated from the contact surfaces. Suppose, what is that meaning here? Suppose the ball is acting here and another ball, it is placed in a surface here. It is in surface. It's the body 1 and it is body 2. Okay, it is contact here and here also contact point, here also contact point. Drawing the body with the action and reaction forces by removing the contacts in order to calculate the reaction forces by using the various theorems such known as the Lami's theorem or equilibrium conditions is known as the free body diagram. Free body diagram is very important in order to find out or calculate or determine the reaction forces or reaction forces by using various theorems. That diagram is known as the free body diagram. Now, what is the free body diagram of 1? The free body diagram of 1, I am going to show you. Here, this is the contact surface passing through. This is another contact. This is another contact. So, with this is action. This is the weight of the body, W1. Now, W1 is point, W1. And another one, this is the surface. This is the surface. This body is passing through that. That is R1. I am doing R1. Then it is reaction, R2. With some, here it is normal. Whatever here in meeting, that will be some inclination. This diagram, here the action force is the weight. What are the reaction forces? R1 and R2. The action and reaction forces acting on your body. This is the body. This diagram is known as the free body diagram of body 1 here. Similarly, body 2 also you can make it. Alright. That is the concept of free body diagram. Finally, Lami's theorem. What is the Lami's theorem? In order to find out the reaction forces, when either action or reaction forces are there, if you know the one action force and others are direction we know but magnitude are not known, in order to calculate those magnitudes, the reaction forces magnitude, we have to use the Lami's theorem is highly useful. Now, Lami's theorem states that if any body is in equilibrium under the action of only 3 coplanar concurrent forces, then each force is directly proportional to the sine of the angle between the other forces. So to calculate, okay, those 3 coplanar, then this Lami's theorem is highly useful. What is the Lami's theorem? States that is very simple. P, Q, R. There are 3 forces on that. The angles made between is theta 1, theta 2 and theta 3. That means P by sine theta 2 equal to Q by PQ. That is this is Q by sine theta 2, P by sine theta 3, that is equal to R by sine theta 1. So from this, P is the force, theta 3 angle made between other 2 forces, that is theta 3. Q is the force, Q by ratio angle made between other P and R, that is theta 2. And R is the force, R by sine theta 1, Q and P. This is the expression of the Lami's theorem, derived expression of the Lami's theorem. Okay, thus in this session we have studied what is some definitions such as what is statics, what is dynamics, what is kinematics, what is kinetics, what is the coplanar concurrent forces, and what is the Lami's theorem, and what is free body diagram. These are the fundamentals are explained in detailed level in order to understand the engineering mechanics course. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.